All right, and welcome to Absolute Value Inequalities, Level 2. Now for number 1, it says solve for the values of x and graph the solution set on the number line. And I want y'all to first notice that we have this symbol right here. Now I want y'all to think about this. Remember, we read symbols like we read books. We read from left to right, or we read words, right? So as y'all go from left to right, as your eyes are traveling in this direction, what do we hit first? Well, we hit the larger side. So you can think of this symbol as saying larger than, or AKA, we would say we call this the greater than symbol. And actually, remember, this one is actually greater than or equal to because it has that line underneath it. Okay, so when we think about this, well, wait a second. What words have we used to describe the greater than symbol? Well, we use the word or we could also use the phrase outside. Okay, so let's see here. We're going to take this 5x minus 3 and write 5x minus 3 and I'm going to write 5x minus 3. And so wait a second, since it's a greater than or equal to symbol, we need both the less than or equal to and the greater than or equal to symbol. But the question becomes, well, what in the world do I put over here? Remember our rules for absolute value bars. When we take them away, we have to take our constant and make it a plus or minus 8, or a positive or negative 8. And it only makes sense when we view the number line to say, okay, we have to be less than our negative value and greater than our positive value. So let's go ahead and work out both of these off to the side. I have 5x minus 3 is less than or equal to negative 8. Well, what do I get rid of first? My 5, my multiplication, or my subtraction, my minus 3. Of course, we get rid of our subtraction first. That cancels. And I have 5x is less than or equal to negative 8 plus 3, which is negative 5. Now from here, I divide both sides by 5, and I get my first solution, x is less than or equal to negative 1. Okay, or we also have 5x minus 3 is greater than or equal to positive 8. Okay, well, let's see, how do I get rid of my minus 3? I follow the same procedure. I add 3 to both sides. I have 5x is greater than or equal to 8 plus 3, which would be 11. And of course, I divide both sides by 5. And I say, you know what, x is greater than or equal to 11 over 5. All I have to do on my number line is simply go up here, and here, let's switch colors. Just go up here. Let's call this negative 1, and I circle it. And I go over here, 11 over 5, and I circle it. And I ask myself, is negative 1 and is 11/5, are they included into our solution set? Well, since we have x is less than or equal to, or x is greater than or equal to, we can actually shade these in. They are included. Now, if x is every value less than negative 1, where do I find values that are less than negative 1? Well, I find them when I'm going to the left. Okay. Where do I find values greater than 11/5? I find them going to the right. Okay. And we can say anything outside of these two numbers is a solution. So for instance, negative 5, well, that's a solution. Way over here, I could say, oh, positive 12. That's somewhere over there. That would be a solution. And what would be something that's not a solution? Well, 0's in between here. So 0 would be an example of something that's not a solution. All right, let's go on to example number 2. Okay, for example number 2, solve for the values of x and graph the solution set on the number line. Okay. Well, the first thing we do is we circle our symbol, and remember, when it's greater than, that is our or statement, and of course that means we're going to be shading on the outside. Well, let's go ahead and write out our two inequalities. Say, okay, we have negative 4x plus 8 is less than, and negative 4x plus 8 is greater than. And wait a second, less than or greater than to what? When I take away my absolute value symbols, what happens to my 16? It becomes positive or negative. So we can say, okay, less than negative 16 and greater than positive 16. All right, and let's work it out. We know we'll get rid of our addition first, so we can subtract 8, subtract 8. All right, we got negative 4x is less than negative 24. Remember, when I combine two negatives, I'm going more negative. And from here, I can divide both sides by negative 4. And wait a second. I want you to pause the video and think to yourself, what is going to happen when I divide by a negative 4? Go ahead and pause the video right now. Think about it. Okay, hopefully you're back. And we should say, you know what? Our less than symbol actually has to flip to become greater than, and negative 24 divided by negative 4 is positive 6. Okay, let's go on to the right side. All right, we have negative 4x plus 8 is greater than 16. We can subtract 8 from both sides. After our zero pair cancels, we have negative 4x is greater than negative 8. Now from here, how do I get rid of this negative 4? Well, I divide. And wait a second, we kind of have a similar thing happen. Whenever we divide by a negative, our inequality flips to become a less than symbol. And negative 8 divided by negative 4 is positive 2. So how do I write my solution set? Well, let's write it like this. X is less than positive 2, or x is greater than 6. So we can come on down here, we can write 2, we can write 6, we'll circle them both, and ask yourself, are 2 and 6 included in our solution set? Well, if x is less than 2, the answer is no. So we'll shade everything to the left, we'll shade everything to the right. And so some examples of solutions could be, I don't know, negative 10. That would be a solution. Over here, we could say something like 18. That is a solution. But if we wanted some non-solutions, we could look at positive 2, we could look at positive 6, or literally anything in between, like 3 would be not a solution, or even 4. All right, I hope this helps, and I'll catch y'all in our level 3 video.